Welcome to EyeOpener, powered by Siemens. And now, your host, Kurgan Sangha.
Hello, and welcome to EyeOpener, powered by Siemens. On today's episode, I'm delighted to welcome Dr. Natalie Kurgan at Siemens, where we are going to be discussing the topic around data cleansing and the preparation for PdM. So big welcome to Natalie. If you could start off by introducing yourself, that'd be great.
So hi, my name is Natalie. I've been working with Sensei Predictive Maintenance for almost 3 years now, and in my role, I deliver the product to the customer. So we work hand in hand with the customer from the moment the purchase order is signed until they're really operating in steady state, and I pass the account off to a customer success manager.
Perfect. Well, thank you so much for joining me on today's episode. And I guess, let's get straight into this topic around data cleansing and preparation of PdM. So, Natalie, the first question I have for you is just around what are the key steps which need to be taken when it comes to data and PdM?
So this is one of the more complicated topics that customers and even people in my role who are just getting started, it's really hard to wrap your head around because there's a lot that goes into it. So in order to make the best use of PdM, data needs to be a condition indicator and it needs to be in steady state. And sometimes we have to do work on the data in order to fit it into those two parameters. So some of the things that we might do are data aggregation, data transformation, and data cleansing, and sometimes we even need to provide context for that data.
Okay. And I know you touched on a key word, so condition indicator. What does that actually mean?
Yeah, so I guess one of the sort of misconceptions about PdM is that oftentimes we have folks that don't quite understand the AI and machine learning behind it, and they think they can feed it anything they want, and it's going to just come up with these magical, insights into the data, into the machine. And it's not really how it works, though, is it? So the whole point of PdM and the way that we're doing it is to do it at scale. So you can do condition monitoring where you have somebody looking at data and identifying, oh, there's something unusual going on with this asset. We need to go work on it. We're just taking away the need for a person to look at every single data stream. So the data we're looking at still needs to be directly related to the condition of the machine. And if it's not directly related, sometimes it's still useful as context to kind of understand the operating conditions of the machine. Okay. So an easy example would be for a motor. Vibration is a pretty good condition indicator. And if the motor is, for instance, has a variable speed, well, then we'll need that speed as context as well. Even though the speed has no relation to the condition of the machine, it's going to have a relation to what the vibration is doing. So if the speed goes up, vibration goes up, but it doesn't mean the machine is failing.
So Natalie, what would happen if that data is not in the condition indication stage? What would happen?
So in the beginning of working with a customer, we have these sessions with them to kind of understand their asset types. So when we say asset, we're really talking about asset type. We're not talking about every individual machine because, again, scale. So what we do is we have these meetings with the customer to understand what the machine is, how it works, and what data tags or measures are available. From there, we have to figure out, now what? What do we do? So we have to understand, how does the machine fail? And how does it not fail? What does it look like when it's normal? The other key word, aside from condition indicator, is steady state. So we want the data. Basically, what Sensei PdM is looking for is it's looking for data that is flat when it's normal and everything's going fine, and when it's not normal and it's failing, the data is not flat. It's doing something else, right? So it's just change detection. But we have a lot of instances. Think about if you're looking at temperature on a bearing. Well, if you have ambient temperature going up and down throughout the year or throughout the day, that temperature you're reading on a bearing might also be varying. So that's something we could provide as context, or we could even do a data transformation to take the difference in between the two temperatures. And in that case, ideally, you'd be looking at a flat line. So that's perfect for something for Sensei to monitor. The other thing we have to do is understand, the most basic one we do all the time is, are you sending us data when the machine is off? Sometimes it's really hard for a customer to integrate. That's like the hardest part of the process. And so we like to make it simpler on them, is just say, look, if you can't take away the off states before you send it, just send it. But we need a run signal as well, or a motor current, or something to know the state of the machine. And then actually inside the app itself, we can create a virtual measure to remove that off state, because if you don't, you're going to be looking at data it's hard to do without a chart, but it's going up and down. So you might have something, let's say vibration again. Let's say it's normally sitting at, 10, whatever units it is. And every so often it drops to 0 because the machine turns off. One of two things is going to happen here. If you leave those zeros in, you might get false positives that your data has changed, and so the system tells you about it. But the other thing that might happen is it'll get totally desensitized to a magnitude change of 10, which for vibration is huge. So basically what that means is it gets used to seeing these magnitude of 10 drops, and then it might see a rise of 2, which might be a huge indicator of degradation, but it's used to seeing a change of 10, so it's not concerned about it. It's too desensitized. So that's one of the main things we'll do, is remove off states. I touched on data transformation a little bit. We might take the difference between two measures to try and get a flat line out of it, or whatever we determine from our engineering standpoint to try and get a steady state. And then the last thing we need is sometimes to provide context. So that would be your speed for your vibration and things like that.
Okay. No, that makes sense. And could you touch a little bit more into the data transformation side? How does that work in terms of what that involves?
Yeah, so inside the app we have an interface called derived measures. It's basically virtual sensors that we can create. So even if somebody is sending us all process data that by itself might not be a condition indicator, it's just nothing being read on the machine itself. It might be, here's the pressure before the pump, and here's the pressure after the pump, and here's all these independent things that don't seem to have something to do with one another. We might take that into our system, into derived measures, and we can calculate, the actual power that the pump is running at. We might be able to calculate the theoretical power, and then using those, we can calculate efficiency, and now we have suddenly all these other measures that we can monitor that are condition indicators.
Okay. Oh, that makes a lot of sense. And, you touched within the Senseye predictive maintenance app that we have, you touched on the section that we have, which is derived measures. And I guess just for the benefit of our audience, it would be great for you to just talk about what else that involves. So I know you've given a high-level overview of that, but just to get a bit more information around that.
Yeah, so it is an advanced tool. So we don't kind of give everybody access to it automatically, because you can kind of do some damage if you don't know what you're doing. But basically it's a flow editor. So you drag blocks that contain different logic and you kind of connect them, and it flows from left to right. So you have different inputs, you have different logic, like you can sum things together, you can take in vectors and take the last value, you have if blocks, all sorts of things you can do. And then at the end, you connect it to an output. So you can create a brand new measure, and you can do it in bulk. So you can, if you have 1,000 motors and they all have, 10 measures on them, you can remove the off states from all, 10,000 measures with one derived measure. So you can do it in bulk. Usually in the beginning of a project, someone like me will help and create those for the customer. But what we usually see is over time, the customer wants to do it themselves, and they can. There's no reason they can't. It's a bit of a learning curve at the start.
Okay, perfect. So essentially it helps to simplify the process, I guess, because you're able to manage and do it in bulk as opposed to doing it individually. Imagine how long that would take, right?
Oh, yeah, absolutely. And the benefit of having it in the app is that, a lot of people still do it before the data even gets to us. But it's not always easy. It's not easy to know what the data needs. It's not easy to actually do the transformation sometimes. And I can't help them if it's not in Senseye. Yeah. So with it being in the app, they have us that we can back them up.
Okay. And how do you know what the data needs?
That's a tricky one. So we have to look at the data. So sometimes we can get an idea of what it needs just during discussions with the customer if we ask the right questions. Okay. But sometimes the customer doesn't know what the data actually does. They have an idea of what it does, but they might not know all of the influencing factors. By that, I mean context. So what process is a particular recipe, if it's like a food sort of manufacturer, does a particular recipe influence what the machine is doing? And was that known or not known? So we do our best in the beginning without even seeing the data often. And then once we get it in the system, we can always go back and tweak things. So we watch it very carefully once it starts to come in.
Natalie, my next question is focused around how many measures need to be taken in order for Senseye predictive maintenance to work?
So that my answer is it depends, which is a terrible answer. But it does. It completely depends on the data. So we do have some kind of templates that sometimes customers just want to know exactly what data do I need. But our answer is we'll use what you have. And we can even change our definition of what is an asset. So if they're considering one asset to be actually a combination of a motor, a fan, and a gearbox, for us that's kind of 3 assets. But if they don't have the data to support those 3 assets, then it's 1. Right? So we can kind of change our definition of what is an asset for the customer based on the data that's available. And we can help them do gap analysis as well to figure out, okay, what do you need? For instance, I've got a customer who they were so smart with how they onboarded their machinery that the very first asset they onboarded, it was a water tank. And it was just sitting outside. It's not exactly critical. It's just a tank of water. It's just sitting outside evaporating to the sun. And they had exactly one measure on it, which was the tank level. Is this thing going to take down the whole site if it goes down? No. But they saved someone by just putting one thing into Senseye. They saved someone a trip on the rounds. So they became more efficient instantly just by letting it monitor the tank level and getting an alarm when it's going to approach a certain level. So if we're smart about it, you don't need a whole lot of data to monitor in Senseye to get benefits from it, but you have to have realistic expectations. You can't use just 1 or 2 measures and expect to catch every failure mode. We've had many people come to us and say, look, we've had this failure. Why didn't Senseye catch it? I didn't get an alert. And so we have to go in and look at the data with them and be like, well, look, you have this many measures, and we're looking at it in the data now. Looks exactly the same as it did a month ago, 2 months ago. I see no change. There's nothing in the data. And if there's nothing there to indicate that it's in a state of failure, there's nothing for the algorithms to find. They're not going to make something from nothing. So it's good to have realistic expectations, but we will work with what they have.
So I guess, Natalie, one of the questions that I have around this topic is, from a customer perspective, and I guess this whole talk around artificial intelligence, making this assumption that AI can capture when it's going to fail. And you've probably had these encounters with customers where you've had scenarios and we haven't been able to capture the failure in time. So it'd be really interesting to get your views on this whole topic around that and how you feel about that.
Yeah, we just have to be honest with them, don't we? It doesn't work on, it's not just a magical black box we can throw in. I often say it's harsh, but you can't feed it garbage and expect miracles. You have to have a thought about what goes in. The noisier the data that goes in, even if it is a condition indicator, if that data is noisy or really spiky, if the magnitude change in just a normal period is really big, the app might not be able to find slight deviations because it's used to seeing a large band of noise. So we have to have realistic expectations in regards to that, and we have to be able to have the conversation with them of, are you willing to get more sensing on this? Because if you don't, we're not going to be able to catch that failure again the next time it happens. And they're usually, they might not get it right away, but they get it eventually.
To find out more, search Senseye Predictive Maintenance.